Okay. Sorry about that. All right, so 5.1. It's basically stuff we did yesterday, but it's being expanded on. All right, so it's going to be a little bit more complicated, but the basis of it is pretty much exactly the same as what we've been doing yesterday. So, first off, some vocabulary that you'll hear me say a lot in this class. All right, base, exponent, and coefficient. Now, before I tell you what they are, let's see if you can identify them because you should be able to. Which value in the 2x to the fifth is my base? Which value is my base? Nope. The x is your base. What is my exponent? The 5 is your exponent. You guys should know what an exponent looks like at the very least. So that leaves your 2 as your coefficient, which makes sense because it's a number in front of a variable. All right. So your base, that is the value being raised to a power. And remember, a base can be either a number or a variable or both. So it can be just a number, just a variable, or both. In this case, it's just the variable because if it was both, it would be in parentheses, but it's not. Huh? I forgot a word. Being raised to a power. The exponent is whatever the power is. So the power or the number that the base is raised to. An exponent, in this case, at least what purpose that we're using it for, in this case, they will always be numbers. But remember, that's not always true, especially if you have, say, an exponential function where x is actually in the exponent place. But again, you're not going to see those again until math 3. So you don't need to worry about that. For right now, your exponents are numbers. Coefficient. That definition hasn't changed. It's the number in front of a variable. And something to note, the coefficient is typically not included in the base. If the number next to a variable is included, like it's all being raised to a power, it's considered the base. But if it's not included with the base, meaning the x is the only thing being raised to a power, and then it's a coefficient. So now, what's the difference between x squared and 2x? What's the difference between x squared and 2x? Well, 2x it's a coefficient, but think about definition wise. So 2x, you're multiplying 2 to x. That's correct. Right. So 2x is multiplication because you're doing 2 times x. X squared, if you broke it apart, you're multiplying x by itself. So, for example, let's say that we set x equal to 4. If we do 2 times 4, we get 8. But if we do 4 squared or 4 times 4, we get 16, two very different values. The only number that makes x true for both statements. Does anyone know a number that if you square it and multiply it by 2, you get the exact same number? Nope. Nope. So can anyone think of a number that if you square it or multiply it by 2, you get the same number?
Is it 2?
It's 2. We just did 4.
I was thinking about
What the number you get, yeah. So 2 is the only value that makes that statement the same. So 2 squared is 4, 2 times 2 is 4. Which makes sense because you're basically just expanding 2 squared. So exponents happen as a result of multiplying a value to itself. And remember, that can happen multiple times depending on what the exponent is. We talked about this yesterday. So in other words, if I raise x to the third power, how many times am I multiplying x to itself?
3 times.
3 times. If I said x to the 16th power, how many times am I multiplying x to itself? 16 times. All right. So 5 cubed. If I expand it like I did yesterday, what would that look like? 5 times 5 times 5. What is 5 times 5 times 5? You guys got this beautiful thing called a calculator. Use it. Nope. 125. So if you wanted to deduce it, you could always think of it like this. 5 times 5 is 25. Then you just got to think about what 25 times 5 is. If you know anything about money, 4 times 25 is 100. Add another 25 cents, 125. Now, x cubed times x to the 5th. This is review from yesterday. So simplified, what should it be? Simplified, not expanded. X to the 8th. So in other words, if we expanded x times x times x, that's x cubed, times x times x times x until it's, times 5 x's, that's x to the 5th. So again, this represents x cubed. This represents x to the 5th. That's why you add them, because you end up with 8 x's. So if two fractions have the same base, what happens to the exponents? When they're multiplied, you add the exponents. That's review from yesterday. And remember, they have to be like bases, meaning they have to have the same base. So x's go with x's, y's go with y's, 2's go with 2's, whatever. So if I wanted to rewrite this rule, x to the m times x to the n, we could rewrite that as what? X raised to the what? Nope. It's not m times n. It's m what? Guys, what do we do? M plus n. Good. So let's just do some review here. We're not even going to expand them because we did all that yesterday. So 7x squared times 2x cubed. All right. So remember, your coefficients, you're always just going to do what with them? Do we add the coefficients? Absolutely not, because we're multiplying. So we have to, oh my God, guys, we're multiplying them. So we have to, there you go. So what's 7 times 2? 14. So again, just because they're coefficients, that doesn't mean you add them if you're multiplying. You still multiply like normal. It's only the exponents that you add. So my x is x squared times x cubed. What is that? x5. 2 plus 3 is 5. What's 10 cubed? 1,000. X to the 5th times x to the 4th? X to the 9th. Come on, guys. This is a review from yesterday. We literally did this yesterday. Nothing new has happened yet. All right. So we're not going to do the easy expressions. We're going to do the harder ones. So we're going to be looking up here. We're skipping 1 through 6 because we did a bunch of those yesterday. So let's look at the next couple ones. So let's look at number 7. So I usually tell my students just take it one part at a time. So I start with the coefficients first. And remember, coefficients, do we add them? Nope, we multiply. So what's 3 times negative 6? Okay. Now, I got an x cubed next, but do I have an x over here? No. So in other words, what do I need to do with it? Doesn't just bring it down. It doesn't go away, you just got to bring it down. So if you have an expression where there's a base in one, but that same base is not in the other, just bring it down. The y's, however, do have common basis between the two expressions. So what is y squared times y to the 5th?
Y to the 7th.
Y to the 7th. All right, this next one. Now, be careful because we have a 5 here, but this is only negative here. If you just see a negative, but nothing else next to it, number-wise, what technically is that number? A 1. So this is a negative 1. So we're doing 5 times negative 1, which is what? Negative 5. Then we got the p's. What's p cubed times p squared?
P to the 5th.
P to the 5th. And then finally, we have an m to the 8th. However, does it have anything to combine with?
Nope.
Nope, so we just bring it down. How you guys doing?
Pretty well.
All right. So again, this is just review. We're just doing more complicated ones. All right. We haven't learned anything new yet. So 9, walk me through what to do. So someone besides Owen. Or Rajon, because they've been carrying you guys. You do 11 times 10 first, which is what? 110. What do I do next? G cubed times G. Now, if it's not raised to an exponent, what's the unspoken exponent? 1. So 3 plus 1, that's G to the 4th. Good. Then what? The h's. So I have h to the 8th times h to the 8th, which is what? H to the 16th. And then finally what? Bring down that v to the 6. All right. I want you guys to try number 10 on your own. So just number 10. Give it a shot. right, thumbs up if you're ready. All right, let's go over. All right, someone who has not spoken yet today, what's my first step? Multiply 4, -5, and -3. What'd you get? Positive 60. If you think about it, 4 times -5 is -20. -20 times -3 is 60. What do I do next? Someone else. Multiply the f's. So what do I get when I multiply the f's? F to the 15th. 9 plus 6 is 15. What's the last thing that I do? Multiply the h's. What do I get? H to the 5th. 3 plus 2 is 5. So you should have gotten 60, F to the 15th, H to the 5th. Now, 11. Before we do anything multiplying wise, look at it carefully. What's something that you see that we haven't saw yet? Well, kind of, but look closer. Are the numbers coefficients this time, or are they bases? They're bases. All right. So if you look closely here, these numbers are not coefficients anymore, they're bases. But can't we evaluate those? Yeah. So be careful. What is the answer to this one? -4. Why is it -4, not +4? Well, why is it -4 but not +4? What about the way this is written makes this -4? So I've been harping on you guys about this for weeks. When you put this in a calculator, it's not in parentheses. So this is -4. I'm just going to bring down everything else because we're not going to do the multiplication yet. Whereas this would be what? +9 because the -3 is in parentheses. So remember, if there's a negative in front of a number and it's being raised to a power, but it's not in parentheses, meaning the negative is not composed in parentheses with the number, you read it as the number squared times -1. And your calculator will do the same. Whereas if you want to square an actual negative number, you're going to write it in parentheses, both, on here and in your calculator. Otherwise, it does not take into account that the negative is included with the number. Does that make sense? All right, I've been harping on you guys about that for weeks. Okay? So, now that we got rid of the exponents with the numerical basis, now these are coefficients. So now I can do business as usual. So 4 times 9, or -4 times 9. -36. X's. X to the 7th. And the y's. Y to the 8th. So guys, if you have numbers that are being raised to a power and it's a multiplication problem, just evaluate the numbers first and then do the multiplication. All right. Does that make sense? Yes, no, maybe. Yeah. All right. Now, this is kind of more of a challenge, but just think about the exponent rule and what it means. Okay? So instead of numerical exponents, we have variable exponents. But again, just think about the rule and what it means. So first off, we'll do the coefficients. So I got 3 and just a negative. So that's -1. So what's that? -3. Now, the x's. Does it have a partner? No, so what do I do with it? Bring it down. So this is x to the a power. What about the y's? If I do y to the b times y to the f, what is that? Nope. Y raised to the b plus f, because we would add the exponents. All right. And then the z's. Z raised to the c plus g. Good. So guys, just because we put letters in there doesn't mean we can't still write out the exponent rule. We know that we have to add the exponents. The only difference is we just don't have numbers to add. So we just have to write out the expression of adding those two letters. Does that make sense? All right, that's multiplication. Again, straight review from yesterday. Now, this one, division, I briefly talked about it when we did the card sort, but we didn't actually have like a whole lesson on it. So we'll spend a little bit more time on division. All right. So, first off, expanded form. How many x's will I have in the numerator? 9. So take a minute, write out 9 x's. 5, 4, 7, 8, 9. How many x's will I have in the denominator? 7. Now, if we are dividing, what's going to happen? So if we're dividing, what's going to happen that we can do with the expanded form? Is there something that I can do between the numerator and the denominator that you can see? Think about simplifying. What would you do? How? It has something to do with the simplifying of the x's. What can I do with those x's? Let me ask you guys this. What is x over x equal to? 1. So what do you think I can do with those x's? Not simplify all of them to 1, but I can cross out pairs. So what that means is 1 for 1. So if I cross out 1 in the numerator, I cross out 1 in the denominator. And you keep doing it until you can't match up anymore. So you should be able to cross out how many x's? 7. You should be able to cross out 7 x's between the numerator and the denominator. Because at some point your denominator runs out. Then what you're left with in either the numerator or the denominator is your answer. So what's x times x equal to? X squared. Now, what about this next one? 2 to the third times 2 to the eighth. So we know 2 to the third is 3 2's all over 2 to the eighth, which is 8 2's. Now, if I use that same process, how many 2's can I cross out between the numerator and denominator? 3. Now, think about this carefully. The numerator canceled out. So what's technically left in the numerator? Not 0, a 1, because we're dividing. All right. So if it cancels out, you have a 1 left. Technically, this can be written as x squared over 1. We can just simplify that to x squared. Now, how many 2's do I have left in the denominator? 5. So this would be 2 to the fifth. Now, if I go a step further, what would that be equal to? I don't want a decimal. So that's 32 in the denominator, and it's still over what? 1. All right, now let's look at ones where we have multiple. So I have 3 2's on top, 3 x's on top, and 4 y's on top. All over 1 2, 1 x, 2 y's, and a z. So remember, it's 1 for 1 and they have to be like bases. So how many 2's can I cross out? 1. How many x's can I cross out? 1. How many y's can I cross out? 2. How many z's can I cross out? None. So whatever you're left with is your answer. And remember, keep it in the same spot that it is on the fraction bar. So my numerator, let's do it with my numerator first. So what's 2 times 2? I know it's 4, but like how would I rewrite that as an exponent? 2 squared, x times x, y times y, all over what? Z. So if I go a step further, just to simplify the 2 squared, it'd be 4 x squared, y squared over z. So if we look here, look at the expanded versus what we started with and what we ended with. What are we actually doing with the exponents? We're subtracting them. All right, and that's the division rule. So just like how multiplication, you add them, division, you subtract them. That's a good way to remember it because what's true about both those operations? They're the reverse of each other. All right, addition's the reverse of subtraction, multiplication's the reverse of division. So obviously their rules are going to be opposite. Okay, so when you divide like bases, you subtract the exponents. Specifically, I would do the big exponent minus the small and put answer where the big exponent was. In the fraction. So if your big exponent was originally in the numerator, you write your answer in the numerator. If your big exponent was originally in the denominator, you write it in the denominator. The reason that you'd want to do big minus small is so you don't end up with negative exponents. All right, which we'll talk about negative exponents when we get back from spring break. But for now, we want to avoid them. So if I rewrite these as x to the m minus x to the n, or sorry, x to the m divided by x to the n, this is the same thing as x to the m minus n. And that's if we're assuming that m is greater than n. So if m is greater than n, we'll do m minus n. All right, so let's try some. So 13. We have a's. Now, what's my big one? What's my big exponent? The top. So that's 8 minus 3. So big minus small. So we'll get a to the 5th. Now, where will I put that a to the 5th back? Will I put it in the numerator or the denominator? Where was the big exponent originally? The numerator. So I have a to the 5th over what? What happens to the a to the cubed? Well, eventually it cancels out. So it'd be a to the 5th over 1. Or just a to the 5th. So I know we kind of went around our butt to go to our elbow there. You could have just left it at a to the 5th after we did the subtraction. But I'm just showing you that, biggest, it'll go back in the same place as the bigger one. You just got to remember that the smaller one will end up being canceled out at the end. So 6 to the 11th raised to the 6 to the 8th. Or divide by 6 to the 8th. I can't not talk today. So what's my big? 11. So I'm doing 11 minus 8, which is just what? 6 cubed. Now, will that remain in the numerator or go in the denominator? Numerator. All right, so since it's that, we'll leave it as 6 cubed. But we can find 6 cubed. What is 6 cubed? 216. All right. Now, 15 is a little bit different. So, the 7, since it's by itself, it's technically being divided by 1. You always divide the coefficients like normal. Just like how I said, you always multiply the coefficients. You divide them just like normal as well. So what's 7 divided by 1? 7. And then I have b raised to the 5 minus 4. So my answer would be what? 7 times b to the what? 1. So just b. Everyone following so far? All right, let's up the ante a little bit. So, 17. Remember, there's an unspoken 1 here. So we divide 12 by 1, we're still going to end up with a 12 in the numerator. So I'm just going to go ahead and draw my fraction bar and already go ahead and put 12 there. Now, the g's. So what's my bigger one, 8 or 3? So I'm doing 8 minus 3. So I get g to the 5th. Where am I going to put that g to the 5th, the numerator or the denominator? The numerator, why? That's the bigger one. The h's. Which one's bigger, 4 or 5? So I do 5 minus 4. So it'd be h to the 1st or just h. Where am I going to put it, numerator or denominator? Denominator, because that's where the bigger exponent is. So this would be my answer, 12 g to the 5th over h. So does that make a bit more sense what I mean by big minus small, put back where the big goes? All right. Now, 18. So just like the division, so just like how when you do big minus small and put the answer back where the big goes, you can also do the same thing with coefficients. Now, that's an easy fraction to simplify, 1 over 2. But let's say that you couldn't. All right. You could always just divide 8 divided by 4. You get 2. And then the 2 goes back where the 8 is because it's bigger. Or just simplify the fraction. So 4 over 8 is what? How do I simplify 4 over 8? It's what? 1 over 2. Now, we have p to the 11 minus 6. So what's that? P to the 5th. Where's it going to go? Numerator, denominator? Numerator. So if I clean this up a little bit, I have p to the 5th over 2. Everyone following so far? All right. Let's do one more. So let's look at 20. Multiple things to do. So just like I told you, do it one at a time. So we're going to start with our coefficients. What's negative 2 over 10 simplified down to? Negative 1 over 5. X's. So I have x squared minus 1, which is what? 1x. Where's that 1x going to go? Numerator, denominator? Denominator, 2 is bigger than 1. So the x is going to go here. Now, the y, does it have anything to divide into it? Nope. So we're just going to leave it where it is, bring it down, put it in the same spot. And then finally the z's. So I have z5 minus 1. So remember, both of these are 1s. What's 5 minus 1? 4. So I have z to the 4th. Where's that z to the 4th go? In the denominator, because that's where our bigger exponent was. So if I want to clean this up a little bit, this will be negative y cubed all over 5x to the 7/5. Does that make sense how to do those? Yes, no, maybe? Good. All right. So let's see if you can figure these out without a calculator. What's 2 squared?
4,
3 squared?
9,
4 squared?
16,
5 squared?
25,
6 squared?
36,
10 squared. Good.
100,
Now let's do the 2's. The 2's are easy because you just keep adding 2 to the previous. So what's 2 cubed? 2 to the 4th? 16. I'm doing the 2's. So 8 times 2 is 16. 2 to the 5th?
35,
32.
30,
2 times 16 is 32. 2 to the 6th? 64. So 2 raised to any power is easy. All you do is just, if you're looking at a chart, look at the previous one, just multiply 2 to it. And honestly, you can do that for any of these powers. So what will 3 cube be? So if you multiply 3 to 9, what is it? It's 27. 3 to the 4th? Nope. No. 81. Think about it this way. If you have 3 to the 4th, you can think about it this way. It's 3 times 3 times 3 times 3. What's 3 times 3? 9 times 9. That's 81. That's the way you can think about it. All right. 4 to the 3rd. That's 64. 4 to the 4th. I think it's 256. They'll correct me if I'm wrong. Yeah, it's 256. All right. 5 cubed. 125. Good. 6 cubed. 216. All right. Now, the 10s are easy. All you do is just take whatever the previous one is, add a 0 to it at the end. So what's 10 cubed? 1,000. 10 to the 4th? 4,000. 10,000. You just add a 0 at the end. 10 to the 5th? 100,000. 10 to the 6th? A million. So 10 raised to any power is easy. All you do is just add a 0 to the previous one. So in other words, if you start with 10 squared or 100, just think about how far away 2 is from 6. That's 4, meaning you add 4 zeros to the 2 that's already there. Now, guys, this chart is one that you need to know without a calculator. All right. Now, that doesn't mean I'm going to deprive you of a calculator, but it'll make your life easier if you at least know what's on this chart. Okay. Now, last thing we're going to talk about is the power rule. So we're going to, yeah. Dear God. Both of you just go at the same time. Hold hands if you need to. Go.
You get suspended. You have to take these.
Yes.
Yes, you do.
All right. Now, we're going to do one of these expanded forms. So, 2 cubed raised to the 4th power. So now we're in power rule. So that'd be 2 cubed times 2 cubed times 2 cubed times 2 cubed. So if I add 3 to itself 4 times, what is that? 12. So this would be 2 to the 12th. Same thing here, p squared. So p squared 5 times. So it's 2 added to itself 5 times. 10. So that's equal to p the 10th. xm times xm. If I add m to itself, think about this carefully. So we have x to the m plus m. What's another way I can write x to the m plus m? Not x squared, not m squared, because we're adding them. Think about it this way. 3 plus 3 is what? 6. What's another way you could write that to get 6? In terms of multiplication, think about it. 3 plus 3 is 6. If we write that in terms of multiplication, how could we write that? Still using a 3. What times 3 is 6? 2. 2m. Now, we already talked about this yesterday. So, if we use power rule, what are we actually doing to the exponents? Multiplying them. So, we multiply the exponents. So, that means this would be x raised to the m times n. And if you need to see it like this, that's fine. So we're not going to write these in expanded form because we did all that yesterday, but we're going to go straight to simplified form. So remember, you got to multiply it to all the bases, including the big numbers. All right. So for this one, all right, we're going to put a 1 on the x so we don't forget that it exists. I'm going to multiply the 2 to both of those. So what would I get? 2 to the 6 and x squared. 2 times 3 is 6. 1 times 2 is 2. This is not new. We did this yesterday. Now, go a little further. What's 2 to the 6th power? 64. So we have 64x squared. All right. This one, again, any value without an exponent, put a 1 next to it so you know, remember to multiply to it. Specifically the 8. That's the one that most people forget. So, multiplying the 3. What do I get? So 8 cubed, then, and the 6, that's 3 times 2, then p cubed. Now, put 8 cubed in your calculator and tell me what you get. That's a decent sized number. It's what?
512.
512. So this is 512 in the 6 p cubed. So my recommendation, guys, if the exponent's relatively small, just put it in your calculator and get it. So like, I expect you to simplify squareds and cubes. Okay. Fourths, it just depends on how low the base is. So like, anywhere on that chart where a fourth's listed, those are the ones you need to simplify. So that's 2, 3, and 4. And 5. 5 is easy too. All right, last one. So remember, I'm going to put 1s in the places for each base that doesn't have an exponent, including the numbers. And I'm going to multiply this 2 to all 4 exponents. So what do I have? X to the 4th. All right. Now, got to do some simplifying. What's 3 squared? 9. So I have 9x squared over, what's 4 squared? 16x to the 4th. Now, am I done simplifying totally? No. What's the issue? I have a division right here. So I can do x to the 4 minus 2, because that's the bigger minus the small, which gives me x squared. Where do I put that x squared back? Where's the x squared go? Numerator, denominator? Denominator. That's where the bigger exponent is. So I'm left with 9, because the x's are gone now in the numerator, 16x squared. And 9 over 16 doesn't simplify, so we're done. So you gotta check to see if there's anything else you can simplify. Because when you simplify exponents, I want them simplified completely. So, power of a product, again, you just multiply it to all the bases. So this would be 8m bm. Same thing with a quotient. You would multiply it to both the bases. So this would be am over bm. All right, now we're going to do some where we got to do more than one thing. Because we did power rule yesterday. So I want to do some more advanced ones. So let's look at 10. Yeah. All right. Now, remember, always go through and mark whatever bases that don't have an exponent with 1. So you don't forget to multiply that to it. All right. Especially the numbers. I'm telling you right now, the biggest mistake that I see with exponent rules is you forget to multiply the exponent to the number. To the numerical base, I should say. So I'm going to multiply this 2 to all of it. So I know you guys can do 2 times 1 and 2 times 2. So I'm just going to tell you what it is. So 8 squared, x to the 4th over 2 squared, x to the 4th. Now, I need to simplify. What can I simplify? What can I simplify? Something staring you right in the face. It'd be what, huh?
8 over 2.
Nope, can't do that yet. I can do the exponents first. So I have 64 x to the 4th over 4x to the 4th. Something else I can glaringly simplify. Come on, you can do it. I believe in you. We can do 64 divided by 4, which is what? 16. So that's 16x to the 4th over x to the 4th. There's one more thing I can simplify. It's blatantly obvious. The exponents. All right. So if you want to divide these, I have x to the 4 minus 4, which is x to the 0. What did I tell you yesterday? Anything raised to the 0 power is always what? 1. So guess what happens to those x to the 4ths? They go bye-bye. They cancel out. So my answer is 16. So guys, if you ever see the same exact base over itself, it automatically cancels out with the same exponent and everything. All right. Let's try 12. Now, we're going to assume, since it's in parentheses, that this negative is with the 4. So when we raise it to a power, we're going to include the negative when we square it. All right. So if the negative is in the parentheses and it's being raised to a power, include the negative with the number. All right. Now, if there is no number, make sure you put a -1 and square a -1. Okay. So if I multiply this to everything, this will be -4 squared. A to the what? 24th. 12 times 2. B to the what? Squared all over what? 9 squared and see the 10. I can do some simplifying. So what's -4 squared? Oh, come on. You guys don't need a calculator for that. What's -4 squared? Not -16. +16. It's in parentheses, so we don't need the negative. Now, there's nothing to simplify with the variables, so we just leave them as is. What's 9 squared? 81. And then that'll be C to the 10th. Now, I'm pretty sure 16 and 81 don't simplify further. So we're going to leave it like that. All right. Last one I want to talk about. Look at 13. So this is multiple rules happening at once. So if you have multiple rules happening at once, I always tell my students, do the power rule first. I don't care what you do after the power rule. You can multiply or divide after the power rule, but you need to do the power rule first if you have multiple things going on. So what am I going to do? Where is it? Where's the power rule? It's a power being raised to a power. Where's the power rule? It's where the p squared and the 5 is. So I'm going to multiply 5 to the p squared. Why am I not going to multiply it to the 2? It's not in the parentheses, so it doesn't apply. So I have 2 p to the what? 10th over 10 p to the 6. Now I got some division rules. So 2 over 10 simplifies down to what? 1 over 5. All right. Now, p's. We have p to the 10 minus 6, which is what? Where do I put it? Numerator, denominator? Numerator. So that's where the bigger one was originally. So if I clean it up a little bit, p to the 4th over 5. So again, if you're doing multiple rules in one, my recommendation, it's not really a recommendation, I'm imploring you, do the power rule first. So if you don't know which rule to start with the power rule, if there is one. After that, I don't care the order. You'll end up being the same thing. So like, let's say you had a combination of all three. You had multiplication, a power rule, and division. Do the power rule first. Okay, so that's it for today. Now, here's what you guys need to do. So I already assigned the 5.1 Delta Math, but I don't want you guys working on that right now. What I do want you to be working on is you're going to do a quizzes on this. And it is going to be taken as a quiz grade, 20 questions. Okay? So you should be able to get through most of it. If you don't, it's homework. So here's what you need to do. I want everyone looking at me right now. Stop moving and look at me. Or look at the board. Here's the directions to how to get into my quizzes classroom. It's already assigned to you in quizzes. So you need to go to my announcements in Canvas. Click on the announcement that says quizzes join code. When you open the announcement, there's a link. Click it and it will automatically generate you in my class after you log in to quizzes. All right. Then there should already be an assignment labeled exponent rules quizzes. You get 2 attempts on it. Now, I said it's due by the end of class, but I'm going to make it due by tomorrow. So by the end of class tomorrow. So due by the end of class tomorrow for a quiz grade. All right. So you can start it. All right. At the very least, in this next 15 minutes. It's just exponent rules. It's open note. Okay. It's completely open note. It's not open friend though. At the very least, I want to make sure you get into my quizzes classroom. All right, that's why I want you to do that right now. You need to get into my quizzes classroom. So that if you have issues,